Now let's start off with the reaction between metal carbonates and acids and metal hydrogen carbonates and acids. For this, first we need to understand what actually are metal carbonates and metal hydrogen carbonates or hydrocarbonates. Now, metal carbonates are nothing but a metal which is in a compound with CO3 group, which is carbonate group, and a metal hydrocarbonate is nothing but a metal which is in a compound with the HCO3 group, which is hydrocarbonate. So an example for both would be sodium carbonate for the metal carbonates and sodium hydrogen carbonate for the metal hydrocarbonates. Now the general reaction for both is the same with acids. When you react either sodium carbonate or sodium hydrocarbonate with an acid, what you get is a salt. You get the evolution of CO2 gas and water. Now the characteristic of this reaction is the CO2 gas evolution. How do you check this? For this, we're going to set up an experiment. Now for this experiment, you need some apparatus which are as follows. You need 2 test tubes, 1 test tube stand, some lime water, some dilute hydrochloric acid, sodium carbonate, and if you want to carry out the experiment for sodium hydrocarbonate, you can also take sodium hydrocarbonate. And you need a thistle tube, a delivery tube, and a rubber cork. Now, what you're going to do is, you're going to fill 1 test tube, half fill basically, with sodium carbonate or sodium hydrocarbonate. And then you cork this. The cork has to have 2 holes into it. One for the delivery tube, the other for the thistle tube. Then you clamp this test tube to the stand. And then you have the other test tube in which you're going to fill some lime water. Now, just keep the test tube with the lime water at the end of the delivery tube and start adding the dilute hydrochloric acid through the thistle funnel into the sodium hydrocarbonate or sodium carbonate. Now, you would see that there is a generation of gas which is indicated by bubbles. And then, as you see the gas coming through the delivery tube, you can see that there are certain changes in lime water. The change is quite clear as lime water turns milky from clear. The other thing that you can do is you can also keep a burning match at the end of the delivery tube. Now, as CO2 does not support burning, the match would no longer burn and would go out. Now the reason for this milky texture of lime water is because of the white precipitate which is formed on the reaction of calcium hydroxide, which is your lime water, and the CO2 which is from the test tube of the previous reaction. Now this forms the white precipitate which is calcium carbonate and water. The milky color is again, which I'm saying, due to the calcium carbonate. Now what if you don't just stop there and you let the CO2 pass through it over and over and you're passing excess of CO2 into it. So here you're creating another reaction wherein you have the calcium carbonate, which was the white precipitate, which was in water, and you're adding CO2 which is in excess. What you have is calcium hydrocarbonate, which is soluble in water. Now this reaction is quite important to remember as you would need it later, and it would definitely come handy.